talk about the adjustable voltage regulator. So in this topic, first we see the contents of this lecture. So first is definition and types. Second one is pin diagram of LM317 and its working. And third one is application. So basically in this video we will talk about LM317 only. So first, definition and types. So an adjustable voltage regulator is a kind of regulator whose regulated voltage can be varied over a range. Now we will see the types of adjustable voltage regulator, positive adjustable voltage regulator, and the negative adjustable voltage regulator. Now, now we will see the types of positive and negative adjustable voltage regulator. So first, voltage regulator LM317 is the classic example of positive adjustable voltage regulator whose output voltage can be varied over a range of 1.2 volt to 57 volts. So basically, it's the range where it works, and below or above it would. Now, LM337 example of negative adjustable voltage regulator. So if you want to see the negative one, then the example is LM337. So LM337 is actually a complement of LM317, which was similar in operation and design, with the only difference being polarity of regulated output voltage. So basically, both are same only, but there is a polarity difference. That's why it's called negative. So now we will see the pin diagram of LM317. So basically, it has three pins: adjacent, V out, and V in. And this is the front view of the LM317. Now after this, we will see the circuit diagram of LM317. So this is the circuit of LM317. So basically, we can see that the input is like V in is bigger than V out. And here we have LM317, which has three terminals: V in, adjacent, and V out. There are two resistors, R1 and R2, of value 240 and 720 ohm respectively. There are two capacitors, C1 and C2, with values 0.1 microfarad and 1 microfarad respectively. And it's in the V out. By varying R2, we will get the value of R1, and that's how we will get the V out. So we will see now see the working. So voltage across the feedback resistor R1 is constant, 1.25 reference voltage. Basically, it is 1.25 into multiplied by VREF, and that VREF produced between the output and adjacent terminal. The adjacent terminal current is a constant current of 100 microampere. It's a too small value. When we will see the formula, we will apply this and we'll get new formula. So since the reference voltage across resistor R1 is constant, the constant current I flows through the other resistor R2, resulting in the output voltage of, like now we will have the formula V out is equal to 1.25 into 1 plus R2 by R1 into I adjacent R2. This is the formula where I adjacent is 100 microampere, and as we see it's so small, so when we put this in the formula, we'll get the new formula 1.25 1 plus R2 by R1. So now, an adjustable voltage is a regulator that can output adjustable voltages from anywhere in the range of the voltage regulator is designed to output. We have already seen the range. That output in that range we will get the output. LM317 voltage regulator, for example, can be made to output any voltages from plus 1.25 1.2 volt 37 volt. This is the range, and this voltage adjustment is achieved by placing different resistor places values for the resistor R2 below in the diagram. So we will change the values of R2, and that's how we'll get out. Continuing on from our tutorial about converting an ATX PSU to a bench power supply, one very good addition to this is the LM317 positive voltage regulator, which we can use to create a variable voltage power supply. The LM317T is an adjustable three-terminal positive voltage regulator capable of supplying different DC voltage outputs other than the fixed voltage power supply of plus 5 or 12 plus 12 volts, or as a variable output voltage from a few volts up to some maximum value, all with current of about 1.5 ampere. So the final value will be 1.5 ampere. With the aid of a small bit of addition added to the output of the PSU, we can have a bench power supply capable of a range of fixed or variable voltages, either positive or negative in nature. In fact, this is more simple than you think, as the transformer rectification and smoothing has already been done by the PSU. Beforehand, all we need to do is connect our additional circuit to the plus 12 volt yellow wire output. But firstly, let's consider a fixed voltage output. We can change the V out, but now we will see the fixed voltage output. The fixed line volt power supply. There are a wide variety of three-terminal voltage regulators available in a standard TO220 package, with the most popular fixed voltage regulator being the 78XX series positive regulators, which range from the very common 7805 plus 5 fixed voltage regulator to 7824. This is a range and a plus 24 volt fixed voltage regulator. These are the examples we have. So this is also a 79XX series 2 fixed negative voltage regulators which produce a complementary negative voltage from minus 5 to minus 24 volts. But in this tutorial, we will only see the positive 7x axis right, because in this video we decide that we will read the positive values of the fixed three-terminal regulator is useful in application where an adjustable output is not required, making the output power supply simpler but very flexible as a voltage. It outputs is dependent only upon the chosen regulator. They are called three-terminal voltage regulator because they have only three terminals to connect to, and these are in input, common, and output. As we have seen in the circuit, it has three inputs: input, common, and output. The input voltage to the regulator will be plus 12 volt yellow wire from the PSU, and is connected between the input and common terminals. So it will be connected between these two. The established plus 9 volt is taken across the output and common as well. So now variable voltage power supply fixed regulator circuit. So suppose we want an output voltage of plus 9 volt from our PSU bench power supply. Then all we have to do is connect a plus 9 volt voltage regulator to the plus 5 yellow line, as the PSU has already done the rectification smoothing to the plus 12 volt output as we have seen. The only additional components required are a capacitor across the input and another across the output. So we will have two capacitor which we will add at the output. These additional capacitors aid in the stability of the regulator and can be anywhere between 100 nanofarad and 330 nanofarad. The additional 100 microfarad output capacitor helps smooth out the inherent ripple content, giving it a good transient response. This large value capacitor placed across the output of a power supply circuit is commonly known as smoothing capacitor. So basically, this capacitor has the job to clarify the output, smooth output. These active series regulators give a maximum output current of about 1.5 ampere at fixed established voltage of 5, 6, 8, 9, 12, 15, 18, and 24 volts respectively. But what if we wanted an output voltage of plus 9 volt but only have a 7805 plus 5 regulator? The plus 5 volt output of the 7805 is reference to the ground GND and 0 volt terminal, which we have seen the circuit. So if we increase the pin 2 terminal voltage from 0 to 4 volt, then the output would also rise by additional 4 volt, providing there was sufficient input voltage. Then by placing a small 4 volt Zener diode between the pin 2 of the regulator and ground, we can make a 78055 volt regulator produce a 9 volt output voltage as well. So that's how we can produce a plus 9 volt, as it's not in the basic stabilized voltage of our regulator. So now we will see the applications. It can be used as a power supply. It is used in programmable output regulation. And one of the most common examples is the mobile charger. We use this in mobile charger. The adapter is supplied with an AC signal. However, the output voltage signal is a regulated DC signal. Uh, so that's all the applications of this. And if you want to know more, like output voltage regulation is good to very good. Like these are basic range, ultra fast voltage correction speed, and versatility of. So EVR can help adjust voltages to safe levels, but can also provide surge protection against electrical surges, spikes, and generator. These are like the most used applications of this. So as we have seen in the circuit, like here, this is the front view. And in circuit, we have seen that by changing R2, we can get a different output, and that will range given the range we want. So that's all from my side. Thank you.